Let's begin section 2.1, basic set concepts. Okay, so a set is simply a collection of objects. And the objects don't have to be numerals, however many times in mathematics they are. But you guys taking this class could be the set of students in Prevet's Online Math 1332 class. The objects in a set are called the elements or members of that set. A set must be well defined. In other words, the elements must be clearly determined. For example, we can't talk about a set of short people. What I determine to be a short person and what a basketball coach determines to be a short person may be two completely different things. However, if I clearly set some boundaries, I could talk about, for example, the set of people who are less than 5'10", right? Or the set of people who are less than 5'6". Clearly determined. Capital letters are generally used to name sets, and there are three methods used to designate a set: the word description, the roster method, and set builder notation. The word description simply uses words to describe the set. For example, W is the set of days of the week, right? The roster method actually lists the elements inside a set of braces, and sometimes you see this as the roster method or the list method. So W is, anytime you see braces, it indicates it's called the set. So W is the set with elements: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Set builder notation uses this format down here, where again the braces are always read the set, right? So the set. The X is read of all X, and the vertical line such that. So we would read this: W is the set of all X such that X is a day of the week. So set builder notation always has this beginning part right here. Always. That's a part of every set using set builder notation. And then we either use a description in English or mathematically. For example, I could say the set of all X such that, okay, X is an element of the natural numbers and X is less than 3. So using math notation or English, either way to describe the set. The empty set is a set that contains no elements. And here's two ways you can designate the empty set. Okay, an example of an empty set might be the set of students in Prevet's Math 1332 class that are less than 5 years old. I will assume that's an empty set. Okay, this symbol is used to indicate that an object is an element of a set. In other words, we might say 3 is an element of the set 1, 2, 3. Right? If I put a bar through it, of course that means it's not an element of the set. Cardinal number is what we call the number of elements in a set. Okay, and here's the notation for that. So for example, if this were our set A up here, then the cardinality of that set is 3 because there are 3 elements in this set. To help us remember what this means, we can think of this as being the number of elements in set A is the cardinal number, or the cardinality is the number of elements in set A. Equivalent sets are sets that contain the same number of elements. In other words, they have the same cardinality. Right? Equal sets are sets that contain the exact same elements. Notice all equal sets must be equivalent, but just because sets are equivalent does not mean they are equal. One-to-one correspondence means each element of set A can be paired with exactly one element of set B. In other words, if they have the same cardinality, you can place sets in a one-to-one correspondence. A finite set is a set with a finite number of elements, and an infinite set is a set with an infinite number of elements. This is the set of natural numbers, and this is the main set of numbers we'll be working with. Notice the capital N. Natural numbers are also called the counting numbers, so that may help you remember what the set of natural numbers are. They are the counting numbers. If you were asked to start counting, you would start with 1, 2, 3, 4, 5. That is the set of natural numbers. Okay, so let's practice some of this. If it said, write a word description of the set Saturday and Sunday, I would say the set of days in a weekend. You might also describe it as the set of days that begin with the letter S. Okay, express the set of the 4 seasons of the year using the roster method. The roster method means I'm just going to list the 4 seasons in my set notation, so inside the braces. So I've got spring, summer, fall, winter. I hope you excuse my penmanship. It's very difficult to write for me with this tablet. Okay, express the set of all x such that x is an element of the natural numbers and x is less than 6 using the roster method again. The roster method is simply a list. Now I've got to know that the natural numbers are 1, 2, 3, 4, ... So if I want those that are less than 6, now notice it doesn't say less than or equal, so I'm not going to include 6. So 1, 2, 3, 4, 5. If it said less than or equal, I would have added 6 to my list. Determine which sets are the empty set. This is not an empty set, right? Not the empty set, because it has an element in it. The set of all x, such that x is a living U.S. president born before 1200. Well, if they're still alive, I'm going to say that they cannot have been born before 1200. So this is the empty set. Yes, empty. Now, notice the difference between this set and this set. The set of all x such that x is the number of living U.S. presidents born before 12. Well, the number of living U.S. presidents is represented by this set right here. The number is 0. So again, this set is not an empty set. But if it asks me to actually list, it is the presidents, here would be my list. There would be none in there. It is the empty set. So be careful about the wording and these small little distinctions. Okay. What about this? Determine whether each statement is true or false. Again, I got to be very careful about my symbols and the wording. 3 is an element of the set with elements 1, 3, 5, 7. Well, of course it is. There it is. So this is true. 4 is not an element of the set of all x such that x is an element of the natural numbers and x is even. Well, it might be convenient to turn that into my roster method. So if it's an element of the natural numbers and they're even, since the natural numbers start with 1, This is 2, 4, 6, 8, dot, dot, dot. There's another way I can write that set. And here it's very easy to see that 4 is indeed an element of this set. So that's false to say that it is not an element. 20 is an element of the set of all x, such that x is an element of the natural numbers, and x is less than 20. Well, I can tell right away if it's less than 20, strictly less than, 20 is not going to be a member of that set, so this is also false. Find the cardinal number for each set. Okay, 1, 3, 5, 7, dot, 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 21. I see it's the odd numbers. So I can count up on my fingers, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and see that that is 11. Or I can think about the numbers from 1 to 20. Half of them are odd, half of them are even, and get that there are 10 odd numbers, and so 21 is one more odd number. C is the set of all x such that x is a day of the week that begins with A. Well, since our days of the week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, none of those days begin with the letter A. So this is the empty set. All right, if I were to write this set in roster form, and so the cardinal number for this set is 0. Right? There are no elements in that set. B is the set of all x such that x is a letter in the word 5. Well, again, if I were going to write this as a list in my roster form, the set would look like this. And so the cardinal number of that set is 4 because there are 4 elements in the set. Now, let me caution you, what if it said that B is the set of all x such that x is a letter in the word, let's say, seen? The cardinality of that set, again, sorry about my penmanship, the cardinality of that set is 3 because when we're listing the elements, they must be distinct elements, right? So I would only list an S, one E, and an N. Those are the elements, distinct elements, in the set of letters in the word seen. So the cardinality of this set would be 3. Okay, D is the set of all x such that x is an element of the natural numbers, and x is in between 2 and 7, including 2. So if I'm going to write that again, or think about what that is, maybe in roster form, the natural numbers starting with 2, including 2, and going up to 7, but not including 7, I can then see that the cardinality of D is 1, 2, 3, 4, 5. Okay, determine if these sets are equivalent, equal, or both. To be equivalent, they have to have the same number of elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So they're at least equivalent. To be equal, they have to have the exact same elements, which they do not. So these sets are simply equivalent, but not equal. Okay, as we were just talking about, there's no need to list the elements twice. So this is in reality the set 0, 1, 2, 3. Okay, so this cardinal number is 4. This cardinal number is 4. So they're at least equivalent. Now, again, in sets, the order you list them in doesn't matter either, as long as the elements are the same. So these sets are equal. They have the exact same element in the set. All right, one more. The set of all x such that x is an element of the natural numbers, and it's between 200 and 206 inclusive. In other words, including 200 and 206. So I might, again, change that to roster form just to be sure. So it's going to be 200, 201, 202, 203 dot 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 206. And over here I've got a set of all x such that x is an element of the natural numbers, and it's between 199 and 207. So it doesn't include 199 or 207, so I'm going to start at 200, 201, 202, and go to 206. So now I can see that these sets are identical. They are the exact same set. These sets are also equal sets. Okay, so you can go now and try to do your homework on this section. Please let me know if you have any questions, and I'll look forward to talking to you in the next video.